Hi, it's good to see you guys again. So today we will talk about section 7.7. And before we start, don't forget you have a quiz today, and then don't forget to catch up with your homework. Oops. So section 7.7, solve rational equation. The way that we solve it is by identify and multiply the least common denominator. What's that mean? So such as, we have a equation 2/3 of x minus 5z equals to 3/4. And you want to multiply each term by the least common denominator. So what's the least common denominator? We have 3, we have 6, we have 4. So that should be 12. That means I want to multiply each term with 12. Okay, after I multiply the least common denominator with 12, the next step is you want to reduce the fraction. So here you have 4, here you will have 2, here you have 3. So the next step is you want to reduce the fraction. Okay, I have 8x minus 10 equals to 9. And then the last is you will want to combine the like terms. I add 10 on both sides. I have 8x equals to 19. I divide by 8. So x is equals to 19 over 8. Okay, so what's our method? Our method is what? We want to identify the least common least common denominator. And then we multiply each term by the least common denominator. So this we will apply the same process to solve the rational equation. But when it comes to rational equation, we need to be aware of the domain, which is the denominator that can't equal to 0. I'm going to talk about that later. So for example, I have 5x plus 5 over x plus 2 at 3x equals to x squared plus x plus 2. Okay, so for this one, what's the least common denominator? Well, let's identify each term's denominator. So the first one is x plus 2. The second one is what? You can view it as 1. The third one is also x plus 2. So no doubt the least common denominator should be x plus 2. So what you want to do is you multiply each term by the least common denominator. So I will have 5x plus 5 over x plus 2 times x plus 2 at 3x times x plus 2 equals to x squared over x plus 2 times x plus 2. You reduce the fraction. So I have 5x plus 5 plus 3x times x plus 2 equals to x squared. And then you can distribute the x inside the parentheses. So I have 5x plus 5 at 3x squared plus 6x equals to x squared. You combine the like terms. So I have 3x squared at 11x at 5 equals to x squared. What would you do from here? Well, to solve the equation, we can set the equation equals to 0 first. So we want to subtract x squared on both sides. So I will have 2x squared plus 11x plus 5 equals to 0. So let's refresh how to do the cross multiply. We want two numbers multiplied together equals 2x. So we have x and 2x. We want two numbers multiplied together is equals to 5, where 5 times 1 equals to 5. And we want the cross product, the sum of the cross product equals to 11x. So x at 10x, which is equals to 11x. So this is one of the factors, this is the other factor. So I have x plus 5 times 2x plus 1 equals to 0. So x is either equals to 5 or x equals to 2x plus 1, which is negative 1/2. Okay, what do I mean? You need to be careful about the domain. So let's take a look. Let me use a purple one. Okay, so you see the domain is here, x plus 2. When it comes to fraction, what do we know? We know that the denominator, they can equal to 0, such as a divided by 0. This doesn't exist or underdefined, or a can be any number, such as -4 divided by 0. No, you can't. You can let the 0 in the denominator. What I mean is, the x can be anything except for what number that makes the denominator equals to 0. Well, that means we have to check our solution. So we have a -5. We want to plug x equals to -5 back into the denominator to check if this is equals to 0. So I have a -5 at 2, which is not equal to 0. So that means this is our solution. We have a -1/2 at 2, also is not equals to 0. So this is also our solution. So now we can circle the solution. So now let's do another one when the denominator has more than one factor. Okay, I have x and then x plus 2 at 1 over x plus 1 equals to 5 over x plus 2 times x plus 1. Okay, so this one has more than one factor. But still, we already experienced this before, right? We know how to find the least common factor, which is x plus 1 times x plus 2. So that we need to multiply each term, remember it's each term, by the least common denominator. Okay, we'll reduce the function. So I have x times x plus 1 at 1 times x plus 2 equals to 5. We simplify the function. We have x squared plus x, and then plus x plus 2 equals to 5. We combine the like terms. Set the equation equals to 0. And then what? We want to factor it. So I have x plus 3 times x minus 1 equals to 0. Use the AC method. Okay, so x equals to -3 or x equals to 1. Again, you want to go back to check the solution. Make sure that you don't have a solution that multiplied together is equal to 0. And then we have totally 3 denominator. Which one you should check? Well, actually, none of these 3. What you want to check is the least common denominator. Why I want to do this? Because the least common denominator is including every of these factors. So that means if the least common denominator doesn't including 0, that means none of these is equals to 0. Okay, so now let's plug in -3 into the least common denominator. Well, we know that this is not equals to 0. So we can circle this. And then I have 1 plus 2 times 1 plus 1, which is also equals to not equal to 0. So we know that x equals to 1 is one of our solution. Okay, so in this previous example, this one is already factored. What if we have some equation that is not factored, such as this one? What would you do? You want to factor the denominator first, right? So oops. So when I factor it, I use the AC method. I have, oh, this should be 2, not 2x, sorry. So this should be x minus 2 times x minus 1. Okay, now I can identify the least common denominator, which is equals to x minus 2 and then x minus 1. And what I want is I want to multiply each term with x minus 2 and then x minus 1. And now I can reduce the fractions. Okay, so I have x times x minus 2 minus 1 times x minus 1 equals to 11. Aha, we see the negative sign. When you see the negative sign, what you need to do is you need to be careful, really, really careful about the sign, because when you distribute the negative one inside the parentheses, it will change the sign of the terms. So now let's distribute inside the parenthesis. I have x squared minus 2x, negative 1 times x equals to negative x. Negative 1 times negative 1 is equals to positive 1. Now I combine the like terms. And I want to set the equation equals to 0. Okay, now use AC method. I have x minus 5 times x plus 2 equals to 0. So x is equal to 5 or x equals to negative 2. Again, this is not done. You want to check your solution. Make sure that when you plug in the solution, the least common denominator is not equals to 0. So you want to check 5 minus 2 times 5 minus 1. Okay, not equals to 0. I have negative 2 minus 2. Okay, negative 2 minus 2 is not equal to 0. It's equal to negative 4. So this is not equal to 0. That means this 2 is our solution. Okay, next, what if we have some numerator has more than one terms? Such as this one. X squared minus x minus 3 minus x plus 2, s plus 2 equals to 5/8. Okay, for this equation, what's the least common denominator? Which is x minus 3, s plus 2, and then 8. Okay, so we want to multiply each term with the least common denominator. And then you reduce the fraction, you will have this one. X minus 2 times x plus 2 times a minus x plus 2 times x minus 3 times 8 equals to 5 times x minus 3, and then x minus plus 2. Okay, some of you may already find there's something wrong with the equation. You may already notice that. So in this equation, what you can see is to multiply everything about the parentheses, right? But this is not true. When you look at step before, previous step, you will notice the least common denominator is multiply the whole fraction, not just a single term of the fraction. So how to avoid this mistake? Well, it's really easy. You just need to put the parentheses on the numerator so that you know that, hey, we want the whole least common denominator multiply the whole numerator, not just one of the terms from the numerator to multiply the least common denominator. So that's how you avoid a mistake like that. So next step is you FOIL it. Okay, so this is for x minus 2 times x plus 2 is what? It's the differences of the square, right? So, oops. This is equals to x squared minus 4 times 8, subtract, and then you FOIL this. Or you might see the answer right away because this is AC method. By AC method, we get to this factor. Think about how you anti or reverse way to do the AC method. You have x squared. The second term should be these two, the sum of these two, which is negative 1x. And then the third term should be the multiplication. You multiply these two terms, the product of these two terms, which is minus negative 2 times negative 3 is negative 6 times 8 equals to, if you don't know, you're not familiar with how to do this reverse way of AC method, you can just FOIL it. So you have x squared plus 2x minus 3x minus 6. Okay, then we distribute the 8 inside. Okay, so here you have a negative sign and you have an 8. You can either distribute the negative sign inside the parentheses first or distribute 8 inside the parentheses first. I would like to distribute 8 inside first. Now let's combine the like terms in here. Okay, continue to simplify by removing the parentheses. At ax at 48 equals to 5x squared minus 5x minus 13. Okay, combine the like terms. These two the same. We have ax negative 13 to add 48 is what? 16, positive 16 equals to 5x squared minus 5x minus 13. And then we want to set the equation equals to 0. So I subtract ax on both sides. and then subtract 16 on both sides. And then we use what? Cross multiply to factor it. So we end up to have what? X plus 2, and then 5x minus 23 equals to 0. And then we have x either equals to -2 or x equals to 23 over 5. Again, we want to check the solution by plugging to the least common denominator. Well, -2 add 2, this is equal to 0. By the zero product rule, 0 multiply everything equals to 0. So this is equal to 0. So that means this can be our solution, because look, if -2 is the solution, if I plug into here, we will have a denominator equal to 0. In the rational equation, you can't have a denominator equals to 0. Okay, so the next is another solution, 23 over 5 minus 3. Well, this one is not equal to 0. Then this add 2 again is not equal to 0. So that means this one is our solution. Okay, so some of you might be notice easier way to do exactly the same equation. I know this is the way that the book did, but we can use something else. Well, you may already notice, why don't you just simplify the equation first? Because you have x plus 2 and then x plus 2. You can just simplify it by, let me use another color, by 1 at beginning, so you will save, you will make the whole calculation. It's easier, right? So let's try this way. X minus 2 over x minus 3, subtract x plus 2 over x plus 2 equals to 5 over 8. So this one is what? Basically, this is equals to 1. So why don't we just do x minus 2 over x minus 3, subtract 1 equals to 5/8. Now, what's the least common denominator? We have x minus 3 and then 8. So now we want to multiply each terms with that. Okay, so then we distribute the 8 inside with ax minus 16, subtract ax minus 24 equals to 5x minus 15. Okay, remove the parentheses and change the sign, plus 24 equals to 5x minus 15. Okay. And then what? Well, and then we combine the like terms up, sorry. ax, negative 16 at 24, we have positive 8 equals to 5x minus 15. And then we solve for x. We add 15 on both sides we have 23 over 5x divided by 5 on both sides. So I have x equals to 23 over 5. Again, we need to check if this is equals to 0. So we want to plug in this one into our least common denominator. Well, this is not equal to 0. That means this is our solution. So look, compared to the book that told us, wow, this is really complicated. Lots of calculation, right? Lots of work, but that's okay. And then this one, we simplify it first, we still get to the same solution. So in the future, it will be easier if you see the equation. The first step to do is try to simplify first, because maybe sometimes you can simplify the step, right? Okay, so that's it for today. Don't forget, we have an extra credit project. Make sure you do it by the end of this week. Get some extra credit. I'll see you next week. Have a good one. Bye-bye.